That's right.
Ever think about how a 19th century French philosopher might have actually laid the groundwork for the AI we use constantly?
It sounds surprising, doesn't it? But the connections are quite direct.
And maybe even more surprisingly,
Right.
where that very foundation kind of reached its limits.
Exactly. That's the core of it.
So that's our mission today. We're going deep into Auguste Comte's positivism,
Hmm.
how it, shaped AI's beginnings and its big successes,
Mm-hmm.
but also where it fell short, and crucially, how researchers now are trying to move beyond that to build AI that's, well, more sophisticated, maybe more aware.
And we've got some great sources guiding us. They really map out this whole evolution in AI methods.
Yeah.
From those purely data-driven roots, based on Comte, towards this growing need for what we call contextual intelligence. We're drawing on work from Iovine, McClure, Vernon and Furlong, Gianchiglia and Bouquet, Siebold, quite a few key researchers.
Okay, great. So our goal then is to give you a much deeper feel for AI's philosophical roots. Hopefully you'll get some real aha moments about why AI acts the way it does.
And maybe some insights into where it's heading as it tries to handle the, let's say, messier parts of our world.
All right, let's unpack this. Auguste Comte, positivism. The core idea basically was if you can't observe it and measure it, it's not really scientific knowledge.
Pretty much. Base everything purely on empirical data, on the phenomena you can actually see and quantify.
And it's kind of wild how directly early AI, especially machine learning, just grabbed onto that idea.
Oh, absolutely. The first wave was deeply positivist. It was all about gathering data, running statistical analyses. That was the main toolkit.
Iovine and Iovine really pointed that out, didn't they? That philosophical alignment was fundamental.
It was. It gave rise to that whole statistical approach.
And you see it leading straight to that iterative refinement process, right? That constant cycle.
Exactly. You design, you test against hard numbers, you update, objectively, quantifiably.
McClure talked about that back in 2014. It's all about proving things numerically. What objectively works?
Which naturally led to the development of those early statistical algorithms.
For things like pattern recognition, classification.
Right. And statistical inference. It let machines learn patterns from data without someone programming every single rule explicitly.
Like Vernon and Furlong showed, this Comtean mindset meant rigorous testing, using clear benchmarks like percentage correct or error rate.
Yeah, made it super easy to compare models, tweak them, improve them, almost like running a lab experiment.
So these formal statistical methods, they became the absolute bedrock, establishing what's correct, making sure results were reproducible.
Vernon and Furlong really stressed that objective empirical data was the foundation, period.
And McClure connects this mathematical formalization, especially in cybernetics,
The study of control systems.
directly back to Comte's way of thinking about knowledge, his epistemology.
It's a really clear link. And it also explains why something like the physical symbol systems hypothesis fits so well then.
Explain that a bit more.
Well, think of cognition or thinking as just manipulating symbols according to formal rules, like chess pieces on a board or numbers in an equation.
Okay.
The machine doesn't understand chess, but it can follow rules perfectly to calculate moves. It's symbol manipulation. And you can statistically analyze if the algorithm doing that manipulation is correct based on the rules. It all ties back to that desire for pure objectivity.
Right, okay. And here's where it gets really interesting, because this approach wasn't just theoretical. It led to huge successes, especially in modern AI, like neural networks.
Absolutely transformative successes. Statistical learning, which is pure positivism in action, is what guides how neural networks adjust their parameters based on empirical data.
To get better predictions.
Exactly. To improve predictions, make the system more robust, more reliable. It fits perfectly with Comte's idea of knowledge building up over time, accumulating based on what's proven.
And the results are tangible. Think about speech recognition. McClure mentioned those models achieving really high word accuracy, error rates sometimes down in the 8 to 14% range. That's pretty good.
It's remarkably good. And that underlying Comtean positivism, it's just everywhere in current AI.
Like in natural language processing.
And natural language processing, intrusion detection, anomaly detection, so many machine learning tasks we rely on every day. Its influence is pervasive.
And the way we evaluate them still reflects that, right? Percentage accuracy, recall, precision.
All quantitative standards. They let researchers make objective comparisons, validate their models. It's the data talking, essentially.
So the focus is squarely on that empirical data. Does it help remove biases?
Well, the idea is that it removes inefficiencies and subjective biases within the algorithms themselves by focusing only on measurable outcomes. It helps build this body of objectively correct knowledge, step by step, constant measurable improvement.
That's a really strong track record. It shows the power of focusing on the objective. But like any framework, it's bound to have blind spots, isn't it?
Inevitable.
So when this purely positivist AI meets the complexities of the real world, where do the cracks start to show?
That's the million-dollar question, isn't it? One major issue is knowledge representation.
How so?
If knowledge is only what you can measure in the data the AI has, then anything not easily quantifiable effectively doesn't exist for the system. That's what Iovan and Iovane found.
So it's like the AI only knows what's explicitly written down, numbered, and indexed.
Yeah.
It misses the stuff between the lines.
Exactly like that. And that obviously limits its ability to perform human-like reasoning or cognition, as Vernon and Furlong pointed out.
Right.
Some critics even say it creates a philosophical disconnect. The AI doesn't grasp the nuances needed for complex, real-world decisions.
I can see that. That kind of rigid, rule-based behavior must be great for predictable tasks, but maybe not so much for ambiguity.
Precisely. You sacrifice adaptability. Vernon and Furlong highlighted that trade-off. When faced with situations needing context or intuition, rule-based systems struggle.
McClure raised a related point, didn't he? Questioning if statistics alone are enough.
Yeah, are they rich enough to determine meaning or context? Or, crucially, the ethical implications of a decision. Statistics give you correlations, not necessarily causation or significance.
It's like knowing that something happened, but not why it matters.
You've got it. And these purely positivist statistical algorithms, they're also quite vulnerable to inheriting biases present in the data. Plus, they often struggle with scalability and generalization. They can be brittle, throw them a curveball, something unexpected they weren't trained on.
And they fall over.
They can fail quite dramatically because they lack that broader understanding, that contextual common sense.
That feels like a pretty fundamental gap, if it only knows what it's fed.
Right. And Ginciglia and Bouquet pointed out a core issue here. These systems have trouble with meaning because they can't determine the content or the why behind a correct outcome. They just know the outcome works statistically.
They can get the right answer without understanding the question.
In a sense, yes. Which really hinders building truly complex, sophisticated AI. And relying solely on quantitative results ignores subjectivity entirely.
Which is crucial for things like moral reasoning,
Yeah.
ethical choices.
Absolutely. Things that aren't easily boiled down to numbers. Statistical techniques alone just don't lead to systems that are context sensitive, that grasp the significance of what they observe, or have ethical discernment.
Is there a good real-world example of this kind of limitation?
Sure, think about natural language processing. The classic problem is word sense disambiguation.
Like the word bank.
Exactly. Bank could be a riverbank or a financial institution. A purely statistical model might know both meanings exist and maybe which is slightly more common overall.
But it doesn't know which one fits this sentence.
Not without more context. If the sentence is, I need to deposit money at the bank, a human knows it's the financial bank. The statistical model might just guess based on probabilities without truly understanding.
And that could lead to errors or weird, inappropriate responses if the context is subtle.
Potentially, yes. Especially in complex situations requiring nuanced understanding. That's the limitation Ginciglia and Bouquet highlighted.
Okay, so that paints a clear picture of the challenge. How are researchers trying to climb out of this positivist box then? What's the path forward?
Well, the exciting part is that researchers are actively exploring new methods. They're looking at different ways of knowing, different epistemologies that explicitly try to bring context back into the picture.
Moving beyond just the raw data.
Exactly. It's a shift away from just the measurable.
And for those meaning-sensitive areas like language, Ginciglia and Bouquet had some early ideas, right? Back in '97.
They did. They proposed two key principles. First, the locality principle, meaning AI should operate within specific domains, understand the parameters of that particular environment, and act appropriately there.
Okay, focus its knowledge. And the second.
The compatibility principle. Basically, design interfaces for AI systems so they can be easily accessed and integrated, maximizing their usefulness.
Makes sense. So how are today's techniques building on that? You mentioned contextual metadata.
Yes. That's a key modern approach. We're using contextual metadata data about the data to give AI systems more dimensions to work with.
Adding layers of meaning or relationship.
Precisely. It helps machines learn, represent, and access information in a richer way, moving beyond just the flat, objective facts.
So things like contextual metadata graphs. You can map relationships between data points.
Exactly. These graphs let AI models build much richer, more adaptable ways to represent and use information that's embedded in context. It's not throwing out objectivity, it's enhancing it, making it more efficient and more meaningful.
So what are the real concrete payoffs of doing this? Integrating this contextual metadata. What's the promise for making AI, well, better, maybe more human-like?
Well, several key benefits. First, you get a much richer, more multifaceted picture of the data.
Because you're pulling in info from different sources, different types.
Right. You're not stuck with that single positivist lens. It's a broader view.
Giving the AI the story around the data, not just the data points themselves.
That's a great way to put it. Second, it lets you combine huge amounts of information without losing objectivity. You get scale and groundedness.
Then it helps with managing all that data.
Definitely. It improves scalability. By understanding relationships, you can reduce redundancy, manage updates more robustly. It cleans things up. And crucially, thinking about ethics, Siebold and colleagues pointed out in 2018 that using things like contextual metadata graphs is pretty essential if you want to build machine learning that tackles fairness, accountability, transparency.
How so?
Because you can build those principles into the structure of the data representation itself, making them part of the system's design, not just an afterthought.
That's huge. So it's not just about performance, it's about responsible AI development.
Exactly. This approach lets AI systems weave together info from all sorts of sources. They can build dynamic, multidimensional data sets that are actually more objective because they capture more facets.
They can build connections, share meanings across different databases.
Yes, ensure interoperability, track governance for accountability. It makes the whole information landscape more robust, more connected, more usable.
Okay, so if I'm getting this right, the path forward seems to be blending that original, strong, objective statistical foundation, the Comtean legacy, with these richer contextual insights. That blend offers a way to tackle those inherent problems of pure positivism we discussed.
That's absolutely the idea. It's about getting a more accurate, more complete representation in the models by understanding both the objective data and its context.
And ultimately, this leads to better performance.
Better performance, increased accuracy, potentially lower costs too, because the AI becomes more adaptable, more efficient, more aware maybe of the environment it's operating in.
It's fascinating. When you look at AI's incredible journey, starting on that bedrock of measurable objective data and now hitting these walls where meaning and context become critical, it really makes you wonder. Can AI truly reach a deeper kind of intelligence by merging the cold, hard facts with the methy, interconnected reality of human experience? Or is it always going to be this incredibly powerful tool, but fundamentally distinct in how it understands?
It's a profound question, and it pushes us to think about how this evolution in AI isn't just changing our technology, it's actively challenging our own definitions. What do we mean by knowledge, by intelligence? What does it even mean to be informed in this world that's getting more complex by the second?